KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Free bus for LKG to 8th standard.
Free, hygienic and nutritious food.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Education Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
In continuation to the last class, right, now we are going to discuss refraction at a spherical surfaces and by lenses. Refraction at a spherical surfaces and by lenses. Okay, right. So in continuation to the last class means here we are going to start it. So almost we started refraction at curved surfaces. Refraction at curved surface, right? So till now we discussed refraction at plane surface. So it is the first class, refraction at curved surfaces. Afterwards we are going to discuss refraction by lens. Okay, so in this class we are going to discuss refraction phenomena due to a single curved surface. Then our discussion will be extended to the two curved surfaces. It is simply called as lens. Okay, right. Now see here, whatever the laws of refraction which is applicable at plane surfaces, the same is applicable at curved surface also. Right? So whatever we discussed regarding the refraction and laws of refraction, the same is applicable at curved surface also. Okay, right. So what are the laws of refraction, So refracted ray, normal, incident ray. Okay, refracted ray, normal, incident ray lie in the same plane. That is the first law of refraction. And the second law of refraction is the sine of angle of incidence. The ratio of sine of angle of incidence to the sine of angle of refraction is constant. That is the second law of refraction. Okay, right. And we already discussed some of the rules while drawing the ray diagram for a curved surface, right, either in case of mirror or here, right. Here means it leads to the lens, right. Whatever the rules we have drawn, whatever the rules we discussed, same rules applicable here also. Okay, right. So what I am saying is, a thin lens is a transparent optical medium bounded by two surfaces, at least one of which should be spherical. So here I am giving the definition for lens, but now in this class we are going to discuss lens means it is the combination of two curved surfaces. It is the combination of or bounded by two surfaces. Sometimes one is spherical, another one is plane. For example, like this. Otherwise, like this. Okay. So one is plane, another one is spherical sometimes. Otherwise, two surfaces may be curved surfaces. So whatever it may be, then which is called as lens. Now our discussion is how the image will be formed in case of curved surfaces. That we are going to discuss. Meanwhile, we will get the relation between different physical quantities which are involved here. Okay, right. So now I will explain you the terminology and ray diagram. Okay, terminology means what is object distance, what is image distance, right? What is the radius of curvature, what is focal length, what is center of curvature, right? And what is image, I mean what is right, what is the image distance, I mean the position of the image. Based on the position of the image we will decide position, image distance, right? So as simple as such, all the definitions we discussed. Okay, but now how the image will be formed in case of single curved surface I will show you, right? So it is the object O, it is the image I, right? So first from the object, incident light, right? This is the incident ray of light is going, will incident on the curved surface, will incident on the curved surface. After this, right, after refraction, this is the refracted ray, right? Here the rays will meet. This is one incident ray, this is the second incident ray. When the ray is passing through pole, right? So here in case of this what? Optic center, when a ray is passing through optic center, it is undeviated and deviated. Okay, so here these two rays will meet, here the image will be formed. It is one medium, it is N1, it is another medium N2, right? So it is totally another medium N2. So it is basically generally glass medium, right? Okay. So automatically it is the image distance, distance of image from optic center, sorry, it is the object distance, distance of object from optic center, it is image distance, distance of image from optic center, it is center of curvature, so it is the radius of curvature. Radius of curvature is the distance of center of curvature from optic center, right? Similarly, here at this point of incidence we are going to draw, we drew a normal, right? So it is a normal, okay, right? So when it is a normal, so we used a letter N to represent. So the normal always pass through the center of curvature from point of incidence, right? Next from N we are going to draw a normal onto the principal axis, right? This is N, right? Here while solving this derivation, that is what I am going to explain for you. N2 by V minus N1 by U is equal to N2 minus N1 by R. Here the small assumption, that is what, this distance is neglected. When the aperture is small, when the aperture of the surface is small, when compared to the rest of the distances like object distance, image distance and radius of curvature, etc., right, this distance will be neglected, right? So this you can feel like Nm, that is the small assumption here. Okay, so this is all about this ray diagram, right? So basically you have to remember two rays are going from object distance. So I already told you, so in case of ray diagram, for our convenience, right, we are taking 2 or 3 or 4 rays, but actually there are hundreds of rays, thousands of rays, lakhs of rays. Okay, so these two rays will meet here, at that point image will be formed. Okay, right. Just you see some information here what I have written. An image I is formed for an object O on the principal axis of a spherical surface with the center of curvature C and radius of curvature R, right? An image I is formed for an object O on the principal axis of a spherical surface with center of curvature C and radius of curvature R. So I already told you, center of curvature is a center point to an imaginary sphere in which spherical surface is a part, in which a spherical surface is a part. Similarly, distance of center of curvature from optic center is simply called as radius of curvature, right? Next, the rays are incident from a medium of refractive index N1 to another of refractive index N2. The rays are incident from a medium of refractive index N1. The rays are incident from a medium of refractive index N1 to another of refractive index N2. Okay, see here. Next, see this afterwards. We have, right, so this is the information about ray diagram. Next, these 2 points are regarding the assumption. Now see this, we are going for derivation. We have for small angles, right? So you know very well tan theta is equal to opposite side by adjacent side. Tan theta is equal to opposite side by adjacent side, that you know. From that we are writing for tan NOM, see here NOM. So for this triangle, right, for this triangle here, I is the angle of incidence, right? Okay. So for this triangle, tan NOM is equal to, right, here Mn by OM. So Mn is the opposite side, OM is the adjacent side. Tan angle NOM is equal to Mn by OM, comma, tan angle NCM, this is NCM, right? This is NCM, okay. So tan angle NCM is equal to Mn by MC, right? This is what opposite side by adjacent side, right? Next, tan angle NIM, tan of NIM. So for this here is equal to Mn by Mi, right? Mn by Mi. So opposite side by adjacent side, okay? Opposite side by adjacent side. Tan angle NIM is equal to Mn by Mi. So this and all I am writing tan theta is equal to opposite side by adjacent side. So because of, due to these three triangles, in case of these three triangles NOM, NCM, NIM, we are writing like this, right? Okay. Now for triangle NOC, it is NOC, see here, NOC. For triangle NOC, I is the exterior angle, right? Okay. So I is equal to triangle NOM plus triangle NCM, right? So triangle NOM plus triangle NCM, okay, right. Next, I is equal to, see already we know what is tan of NOM, that is equal to Mn by OM, no? So that only we are writing here, right? And one more thing is, for small angles tan theta is identically equal to theta, right? So tan angle NOM is equal to NOM, that is what angle at O, that is angle NOM, that only we are writing here, right? This is with assumption for smaller angles of values, for small angles, right? Next, for angle NCM, right? Not for triangle, angle NCM. So here Mn by MC. So I is equal to Mn by OM, plus Mn by MC. It is equation number 1. Okay, right. Similarly R, this is the R, see here. So angle of refraction, similarly R is equal to angle NCM. So angle NCM minus angle NIM, right? So here R is equal to, similarly, so just how we have written here, similarly we have to write here Mn by MC minus Mn by Mi, minus Mn by Mi, okay. So from this, it is equation number 1, it is equation number 2, right? So after this, we know what is Snell's law, which is second law of refraction. So the ratio of sine of angle of incidence to the sine of angle of refraction is constant, okay, right. So from that we are writing here, because This is the medium of refractive index n1 and other one is medium of refractive index n2. So from that we can write n1 sin I is equal to n2 sin r. n1 sin I is equal to n2 sin r. Okay ma? Right. Next, for small angles of I and r, for small angles of angle of incidence and angle of refraction, we can write it as n1 into I is equal to n2 into r. n1 into I is equal to n2 into r. It is like equation number 3. So 1, 2, 3. From these three equations, just I am writing n1 into I means what ma? Mn by Om plus Mn by Mc, right? Okay, plus n2 into r, sorry ma, is equal to n1 into I, that is n1 into this one is equal to n2 into r, so this one, n2 into this one, right? So from that we can, if you do that mathematically, you will get it as n1 by Om plus n2 by Mi, n1 by Om plus n2 by Mi is equal to n2 minus n1 by Mc, n2 minus n1 by Mc. So n1 is the refractive index of first medium here according to our ray diagram, and n2 is the refractive index of second medium. It is like equation 4. It is like equation 4. Next, applying the Cartesian sign convention. Applying the Cartesian sign convention, Om is equal to minus u, Mi is equal to plus v, Mc is equal to plus r. Om is equal to minus u, Mi is equal to plus v, Mc is equal to plus r, right? So you know very well what is the Cartesian sign convention. The distances in the direction of incident ray should be taken as positive. The distances measured opposite to the direction of incident ray taken as negative. Similarly, the distances vertically upward taken as positive and vertically downward taken as negative, right? So this is all about Cartesian Cartesian sign convention, okay, right? So we have to substitute all these things in this equation 4, right? Substituting the above in equation 4, here will give you n2 by v minus n1 by u. n2 by v minus n1 by u is equal to n2 minus n1 by r. n2 minus n1 by r, okay, right? So the above equation, so this is the equation ma. The above equation gives the relation between object and image distance. So u is the object distance, v is the image distance in terms of refractive index of the medium and the radius of curvature of the curved spherical surface. So these are the refractive index of the mediums and radius of curvature of the curved spherical surface. Radius of curvature of the curved spherical surface, okay, right? It holds for any curved surface. So whatever the relation we derived here, that is n2 by v n2 by v minus n1 by u is equal to n2 minus n1 by r, which is true, which is good, which holds, which is good for any curved surface, okay, right? So this is all about the derivation which is called as image formation. This equation is related to the image formation. Finally, you have to keep in mind, this is the equation which relates image distance, object distance and refractive index along with the radius of curvature, okay, right? Now based on this we are going to discuss one example problem, right? See here, light from a point source in air falls on a spherical glass surface. Refractive index is 1.5 and radius of curvature is 20 centimeters, full stop. The distance of the light source from the glass surface is 100 centimeters, okay? At what position the image is formed, right? So as simple as such, he is asking to find image distance, okay? But I will repeat the problem once again, you try to grasp any more is possible, right? And I mean what I am saying is more than that. I can say that confidently he is asking to find only image distance. But you observe once again. See this. Light from a point source in air falls on a spherical glass surface. In the bracket they have given some values, that is refractive index 1.5 and radius of curvature 20 centimeters. Okay, full stop. The distance of the light source from the glass surface, the distance of the light source from the glass surface means what ma? It is object distance u, that is including sign convention, it is minus 100 centimeters. At what position the image is formed? Okay, right. Now we completed to read the problem. Now we are going for solution. See here. Object distance u is equal to minus 100 centimeters as I told just now. V is we have to find. Then R is a plus 20 centimeter. Radius of curvature is plus 20 centimeter and refractive index of here both air and glass, right? Glass means whatever he is talking about, that is what spherical glass surface. Okay, so it is for one medium it is 1 and another one it is 1.5. okay, n1 is equal to 1 and n2 is equal to 1.5. okay, right. So from this formula, what is that? Just now we derived n2 by v minus n1 by u is equal to n2 by v minus n1 by u is equal to n2 minus n1 by r, n2 minus n1 by r. okay, right. So what is n2, what is n1, what is r, what is u, that all clearly written ma. See, just we have to substitute 1.5 divided by v, right. Here minus is there, already u is equal to minus 100, that you have to notice. So minus of minus plus, so plus 1 by 100 is equal to n2 minus n1. So 1.5 minus 1 it is 0.5, right, divided by r value is 20. So mathematically we have to solve this. So if you solve that, we will get it as 100 centimeters, right. So image distance, the position of the image is 100 centimeters. So you can say that the image is formed at a distance of 100 centimeters from the glass surface in the direction of the incident light. So how I can say that in the direction of incident light? Because here sign convention is plus. So plus means it is in the direction of incident light. Minus means it is opposite to the direction of incident light according to the sign convention. Okay, right. So in this class we started to discuss refraction at curved surfaces. Refraction at curved surfaces or refraction at a spherical surfaces. In that discussion, we discussed to derive a formula which relates image distance, object distance, radius of curvature and refractive index. We also understood how image will be formed at a point on a principal axis because or due to the spherical surface. Okay, right. Next we gone through one small example problem related to this formula. Okay ma, right.